Good morning, 8th grade science class. Today we're going to be going over day 6 of our 10-day STAR review. This is going to be covering Earth and space today, and we're going to start off by just breaking down our stimuli like always. That's the picture that's given. In this picture, we have our sun, our Earth, and our moon, and it's showing just different revolution and different rotations. So as you can see, number 1 and number 2, these are revolution, all right? This revolves around the sun, all right? These are our seasons, all right? But also this tilt of the Earth right here, this line that cuts straight through the Earth, it's kind of showing our tilt. This is also going to be part for our seasons. Then we have number 2. It looks like this is the orbit that our moon takes around our Earth. That's orbit. Again, it's going to revolve around our Earth. And then right here, number 3, we have rotation because it's spinning on an axis, and that means rotation, okay? And we can answer the questions kind of using the stimuli now. So which arrow indicates the cause of day and night? All right, day and night is every 24 hours. All right, so let me scoot down a little bit. So which arrow indicates the cause of day and night on Earth? All right, so we're going to need to look at one of these arrows. But remember, day and night happens every 24 hours. Okay, what does the Earth do every 24 hours? It rotates. All right, it rotates on an axis, right? Every 24 hours, and that causes day and night. So when you're looking up here at the chart, the only thing on the axis is number 3, in which the Earth is rotating. This is going to cause day and night. So your answer is arrow 3. Number 2, which arrow shows revolution of a body in space? All right, remember, revolve doesn't mean you're on an axis. It means you're going around something, right? So you're going around something. All right, if you're revolving around, that means you're going around something, okay? We'll kind of show that here. All right, so revolution here, all right, could be 1 and 4. We'll see if it's an option down here. Nope. It could be 1 and 2, right? Because the moon revolves around our planet. Let's see if that's an option down here. Nope. I apologize, guys. Move this up here. So we're just trying to figure out which arrow shows revolution of body in space, okay? I'm going to zoom out so we can see our stimuli and the question a little bit. All right, and so I just drew a little revolution example here, right? Revolves means you go around something, circle around something. And we went up here to the top and we saw that 1 and 2 could work, but it's not on there. 1 and 4 could work, it's not on there. 2 and 4 could work, but it's not on there, okay? So let's kind of break down. So 2 and 3. Well, 2 would be an example of revolution, but 3 is not. 1 would be an example of revolution, and 2 is an example of revolution. Just double check, make sure. 1 and 3 is not a good example, and 3 and 4 would be an example. Anything with 3, guys, 3 is rotation. Yeah. All right, number 3. The tilting of the Earth on its axis contributes to what? So come back over here to our stimuli. The Earth is tilted, all right? Since this tilt, we have an uneven heating of the Earth's surface. Sometimes the northern hemisphere, and we can always draw our hemisphere here too, guys, if we want. All right, sometimes our northern hemisphere and our southern hemisphere get more or less sunlight. So the changing of the season, all right, as Earth moves around the sun, all right, doesn't affect the moon, okay? Doesn't affect our tides. That has to do with our moon phase, okay? And it doesn't really have anything to do with gravity, okay? So your only answer choice is B. But like we said, if you can make every choice 50-50, make yourself a lot easier on yourself, right? Changing the seasons. Number 4, Katrina travels to Australia when the Earth is located at arrow 1, and it is winter. She returns to Australia when Earth is located at arrow 4. What season will it be? All right, so let's look at arrow number 1. She's in Australia, all right, when the Earth is located at arrow 1. It's winter here in Australia. If it's winter here in Australia, okay, she travels to Australia. She travels to Australia when the Earth is located around. She then returns to Australia when the Earth is located at number 4. What season will be in Australia here? Remember, guys, seasons go in opposite. So if it's winter over here in Australia, all right, and remember, Australia is in your southern hemisphere down here, okay, your southern hemisphere. So if it's winter here in the southern hemisphere, it's going to be summer in the northern hemisphere, all right? But when it goes all the way back around, it's going to swap. So we're going to have summer, right, in the southern hemisphere and winter in the northern hemisphere. So it's going to kind of repeat itself. Okay, so good. Your answer is summer. Basically, guys, this is halfway through the year, and we know that our seasons change, right? It's just going to be the opposite season. If she was in spring here, right, in Australia, then she would be in fall when she went on our next vacation. Okay. All right, moving along. Number 5. Sarah observes and records these moon phases. Which phase will she observe on night 15? Okay, so we're going through our moon phases here, guys. And as you see, it's changing every 5 nights. Okay, so it's asking at what phase will it be in one more cycle? One more cycle. All right. Yes, hold on one second. All right, sorry about that. So as you see, guys, it's just our moon phases in order. And so lucky for us, they put it in order for us. So we just have to look at what the next cycle is. And as remember, as light's going to disappear, right? Or as the darkness is disappearing and light's increasing, as light's increasing, as you go from, you just got to push. All right, sorry, let me pause this. Oh, I apologize, guys. There's a lot of interruptions today, okay? But as you see, guys, darkness is disappearing and light is creeping onto the moon. So we got a little bit of light here. Here's going to be our crescent, right? Our waxing crescent. Then we have our, all right, our quarter, all right, first quarter, a waxing quarter. All right, and then it looks like it kind of skips over our waxing gibbous and goes straight to our full moon right here, okay? And that's because it's going every 5 nights instead of 3.5, because our moon phases are normally 3.5 days. All right, so we have to think of what the next cycle is. But so when you go to a full moon, then you have to start taking light away, and light starts to disappear from the right side, okay? Since it exited from here side, it's going to exit from this side. So you're looking for a moon, right, that has a little bit of darkness creeping on, all right? We're looking for a waning gibbous. So when you look down here, A is the only one that has our waning gibbous. Now, if you do the 8th grade science hack, you'll have all your cycles there and you'll just be able to look at that. But that's the best way to handle these questions on moon phases, all right? The 8th grade science hack. All right, so number 6. When we see the full moon rise above the eastern horizon, right? When will you see the full moon rise above the eastern horizon? All right, so whenever you guys see the full moon, all right, that means that you're seeing all of the moon surface lit up. So we're getting a really good reflection of the moon off the sun's surface. So in order for it to be rising as a full moon, that means that you're going to have to be able to see the moon around sunset, okay? You're also going to be able to see it set around sunrise. And these are those examples wherever you see, all right, whenever you see the moon and the sun at the same time, and it's pretty cool, all right? But it's saying, when will you see a full moon rise, all right? And you're going to see the full moon rise, all right, at sunset, all right? So it rises at sunset. When the sun goes down, the moon comes up. All right, number 7. What phase of the moon will you see in this situation, okay? So we have the sun right here, all right? And we have our earth right here. And then our moon is situated right here on the side. So if you look at this diagram, guys, you can kind of see the reflection, all right? Or sorry, you can see the shadow that the earth is going to cast on the sun itself. All right, so best thing to do is just to use your hack and go ahead and draw your phases right here, your moon phases, so you can figure out which this one is exactly, okay? So we know that right when the moon is between the sun and our Earth. When it's right in between, this is called a new moon when it's completely dark. Which means over here, this has to be our full moon when it's completely lit up. And we know that when we go from full moon, all right, all the way back over to our new moon, okay, we have our gibbous, all right, and our crescent on this side, and then we have our waning up here and waxing down here. So if you wanted to, you could just do the whole cycle real quick. All right, you're going to have your waxing down here. Remember, wax means increasing. Okay, and that's just going to be your little crescent, waxing crescent. This is going to be your first or waxing quarter. First quarter. Okay, this is going to be your waxing gibbous, because most all of the surface is lit up. Remember, gibbous means more than half, crescent means less than half. This is your full moon, which means darkness is going to start creeping back on from the opposite side, which makes this waning, right? Gibbous, which makes this waning crescent. You can draw that in if you want. It's almost completely dark again, okay? And this is going to be your quarter, all right? This is going to be your third or last quarter, okay? So right here, we have our waning gibbous. Go ahead and look on your chart and find a waning gibbous. Okay. As you can see, it's right down here, waning gibbous, number 3. All right. And then number 8, which of the following characteristics do the Earth and Moon share in common? Okay. So makeup of the atmosphere. Our moon really doesn't have an atmosphere, doesn't really capture any oxygen. The amount of gravitational force. Well, gravity is a thing on our planet. All right, so let's consider that because our moon does have orbit around it. Approximate distance from the sun. No. We are pretty far from the sun, but moon is a little bit closer. And volume of water on the surface. Well, we don't have water on the surface of our moon. Okay. So actually, well, I made a mistake here, guys. The approximate distance from the sun. I always confuse the two things. The moon and the sun are approximate distance from one another, okay? Good. But our atmosphere, all right, may have anything, but our gravitational force, definitely not, because our Earth is much bigger than our moon, okay? So it can't be our gravitational force. So yeah, we are about the same from the sun. My mistake. That's choice C. Right. Continuing on with number 9, guys. Still continuing on our Earth and Space Unit. We're talking a little bit more about gravity, a little bit of astronauts. So if an astronaut were to walk on the moon and they jump out 2 or 3 times higher than they would on Earth. All right. What is the primary reason for this? Well, it has nothing to do with the lunar atmosphere. Okay. The moon is much less massive than Earth, right? And remember, the 2 things that make up gravity, guys, are size, right? Which is mass, and distance. Those are the 2 things that make up gravity: size or mass and distance, okay? So B could be a good choice, but let's double check. Special suits engineered by NASA? No, it is not special suits engineered by NASA. And astronauts train their muscles for their unique lunar surface. Astronauts do train specifically so their muscles don't lose themselves whenever they're in long travels, but no, it's not for jumping high on the moon, guys. Again, you don't have to know the correct one, you just have to know the bogus answer choices. And we know that C or D are bogus, so we really just made a 50-50 for ourselves, okay? Answer choice B. Number 10, in August 1981, Voyager 2 approached the planet Saturn. During this time, its speed increased from 17 kilometers a second to 34 kilometers a second. Why did this sudden increase in speed occur? Remember, gravity, guys. Remember gravity. Gravity applies to everything out there, and Saturn's a pretty big celestial body. So Saturn doesn't have a magnetic field. All right, the onboard rockets weren't fired. Solar winds had nothing to do with it, but gravity had everything to do with it. The closer it got to Saturn, the more gravity was able to pull it in, and it got closer and closer and it would speed up and speed up. Just like whenever something falls to our planet, it speeds up really fast. Number 11. Even though the sun has a mass 27 million times greater than the moon has a greater impact on Earth's tides. Why is this? Well, guys, the sun is very big, right? But the sun is very far away from our planet, while the moon is very close to our planet, right? And the two things that make up gravity are mass and distance, right? So the moon is much closer to our Earth, okay? The moon has a more gravitational force than the sun. That's not true. If that was the case, then everything would be orbiting our moon, and it's not. It's orbiting the sun. Our sun has more gravity, but it's further away. The moon is made of solid elements instead of the gases. Well, true, but our sun has a whole lot of solid metal and liquids inside, not just gas. And the moon has a faster orbital period, okay? Well, the moon does go around our planet every 24 hours, while we go around the sun every 365, all right, days. But that has nothing to do with our tides, all right? Our tides are pulling water towards either the moon or the sun. And since the moon is a lot closer, it doesn't have to be bigger because it's so much closer than us. So again, we knocked out B and C. Those are improper choices, but A and D, all right, we made it 50-50. A is a better choice. Number 12, which position of the moon will produce the highest tides on our Earth? Okay, so remember, the moon and the sun are pulling water towards them. Okay, they're pulling water towards them. So if you have the moon and the sun lined up, all the water from our planet is getting pulled, right, towards the moon and the sun. If the moon's in any other position, water's being pulled in opposite directions, being pulled away from each other. But if they're working together in position A, right, or in position C, okay, then you're going to have the highest tides. But remember, whenever it's lined up, all right, we call this our high tide. And wherever it's on the side, we call this our neap tide. Okay, so we go through our answer choices. The only one in A and C, choice B. All right, guys, and here is our answer key for our day 6 matching vocabulary. A lot of these words, guys, they're available in your 8th grade STAR booklet. You just have to look at the section. It has all of our vocab there. But a lot of them are pretty easy. When the moon phases are becoming less visible, remember, wax on, wane off. So this is your waning, which means when the moon phases are becoming more visible, that'll be your waxing. The effects of the gravitational effects on the moon on our oceans will be our tidal. We have a new moon, which is when there's no part of the moon visible. A rotational line, guys, that cuts through a celestial body, that'd be your axial tilt. Food main, about 25% of the moon is visible. That will be your crescent moon. The spinning movement, guys, spinning would be rotation, while revolution, all right, is going to be orbiting around something. The phase of the moon where you're half visible is going to be E, your half moon. Yearly climate changes is going to be J, your seasons. The time it takes for the moon to complete its cycle, that's called our lunar cycle. And then the phase of the moon where 100% of it visible, C, that's going to be our full moon. I'll leave this up here for just a sec. And you can always pause the video if you need to. As always, hit that bell icon, like, and subscribe. Thanks so much. Be safe. I go on.